Okay. Feel free to continue dropping things into the chat, but I'm going to get us started. Welcome, everyone, to the California Water Data Consortium's May 2026 Data for Lunch, Co-Creating the Water Future We Deserve, with Ted Grantham of COEQWAL. I'm Elisa Salonis-Centric, the Senior Communications and Outreach Manager at the consortium, and I'll be introducing our speaker today and supporting today's discussion. We also have our CEO and President, Robin Grimm, on the call to help facilitate and moderate today's discussion and Q&A. Here are just a few housekeeping items before we begin. Yes, this meeting is being recorded and will be sent out via email and posted on our website and YouTube channel. Your questions are totally welcome throughout the presentation. Just add them to the chat box in Zoom, and my colleague Avery will be collecting those so that we can address them during the discussion portion at the end of the presentation. And then please complete the post-event survey. Your feedback helps us plan for future Data for Lunch events and offerings. This is today's agenda. Ted's presentation will be about 30, maybe 40 minutes or so. And then we'll have a facilitated discussion with Robin and Ted where we prepared a couple questions ahead of time. And then additionally, Ted's graciously agreed to stay on Zoom for your questions and an informal discussion at around 1 o'clock. So again, please feel free to pop your questions into the Zoom chat throughout today's event. We'll be collecting those. And then for those less familiar with the consortium, we are an independent nonprofit created through a partnership between state agencies and non-state entities. Our mission is to catalyze innovative water management through advancement and use of open data, especially in the face of climate change. And we do this by bringing people and institutions together to share ideas, synthesize information, and design smarter ways to use and share data. Our work spans research, tool development, hosting webinars and panels like this one, shaping policy recommendations, and helping our community come together around a shared vision for open data and climate resilience. Avery's going to drop our website into the chat. She's also going to just drop links throughout the presentation as well. And of course, since you're all here today, you know that our Data for Lunch series is just one way we fulfill our mission. If this is your first time attending, welcome. You can learn more about the series in one of the links that we drop into the chat. We also have some great events coming up in June, including one next week. This is a topic you all have been asking for, so we're super excited to host a great discussion with 3 state data leaders on what's working, what's missing, and what comes next for California's open data platforms and work. And then later on in the month, we are also hosting an event with Upstream Tech, exploring how machine learning is generating reliable stream flow forecasts across California's unmonitored watersheds. So you can register at the links in the chat. These will also be recorded if you can't make it. I know it's kind of getting into like the summer vacation time, so those will always live on YouTube. I'd also like to take a moment to thank our sponsors, the California Department of Water Resources. One second. California Department of Water Resources, Stantec, and Environmental Science Associates for making this Data for Lunch series possible. If you or your organization are interested in sponsoring future Data for Lunch events, feel free to reach out to me directly for more information. Abe is going to drop a link to the sponsorship flyer in the chat. Okay, with all that in mind, I'm excited to welcome Ted to our Data for Lunch today. Ted is an associate professor of cooperative extension in the Department of Environmental Science, Policy, and Management at UC Berkeley, where his work sits at the intersection of river science, water policy, and the communities that depend on both. He also co-directs the Berkeley Freshwater Group and serves as an adjunct fellow at the Water Policy Center at Public Policy Institute of California, or PPIC, And today he's here to talk about COEQWAL, the Collaboratory for Equity in Water Allocations, a project that puts California's primary water planning model in the hands of the communities most affected by these decisions. So I'm going to hand the reins over to Ted for his presentation. Thank you again, Ted, for sharing your work and research today.
Great. Thank you so much for that introduction. Yeah, very happy to have the opportunity to share a bit more about this project, CoEqual, that we've been working on for the past couple of years. Just give me 1 minute to pull up my slides. Sorry,
No
I got it.
worries, take your time.
Yeah,
We can always edit this out too.
excellent. All right, I think we're in business.
Yep, good to go.
All right. So yeah, good afternoon, everyone. Thank you for joining this lunch hour seminar, and thank you also for yeah, again, this opportunity to speak. I think this project really the ethos behind this project really aligns with the goals of the California Water Data Consortium. So it's a great opportunity to connect our work with all the great work that you all are doing. I'm guessing that most of you who are joining this webinar are familiar with the broad water challenges that we're facing in California. Our available water supplies are under intense demand to meet the needs of a growing population, an immense agricultural sector, and environmental water uses that are really critical to sustaining endangered species, fisheries, and migratory birds. At the same time, much of our water infrastructure is under stress from a changing climate, which is characterized by increased precipitation volatility, more extreme floods and droughts, and sea level rise. So it's becoming increasingly clear that our water system cannot serve all of our societal needs as we look to the future. So we're at an inflection point, at a unique moment where decisions about how to adapt our water system to changing circumstances are shaping how we're going to balance our various societal water needs. And so this moment also presents an opportunity, I think, to consider what's possible and to consider who should be at the table when we make decisions over California's water future. This is the moment we're seeking to meet with this project, CoEqual, the Collaboratory for Equity in Water Allocations. And with CoEqual, we believe that charting a path to a more resilient, equitable, and sustainable water future requires a collaborative approach that brings together diverse interests and values to explore possibilities for our water future. Um, Given the complexity of California's water system, it's important that we take proactive steps to lower barriers to participation in water decision making and planning. And as such, an overarching goal of this work is to democratize California's water futures. We specifically aim to uplift the perspectives, needs, and values of communities that have been historically marginalized from water decision making through intentional outreach and engagement. And equity is a central theme of this project. And one of the ways in which we are working to enhance equity is by providing the public access to the same data and tools that are used by agencies and other decision makers. We believe that by making water information more transparent, meaningful, and accessible, we can really accelerate solutions to addressing our water challenges. And finally, as an independent research project, we hope that this project brings value by fostering dialogue in a space that is outside of the, I guess, typical, more contentious venues that often characterize California water. This project was funded through a recent Climate Action Initiative program that was established through a one-time $100 million allocation from the state legislature. This program was designed to support research that advances the state's climate action priorities. Our project was the largest of about 40 that were funded under this initiative, and was the only to focus specifically on California, water planning and climate adaptation. This has been a high intensity, short term effort. and we've been charged with delivering actionable results within 2 years. And fortunately, we received a much needed 1 year extension, and we'll be wrapping up the project at the end of this summer. So this is also a great time to kind of report out on what we've accomplished and what you can expect to see when we release the full findings of our work. Our project is structured around a participatory scenario planning approach in which alternative water futures are explored using a water planning model known as CalSim3. Working with different community partners, we're exploring how alternative operational strategies, such as changes in regulations, water allocation priorities, and infrastructure, combined with different climate futures, affect water allocations for different users, including agriculture, cities, and the environment. We're organizing these scenarios on a web-based data platform where they can be queried and explored by the public. And I think what's really unique about our approach is that we've engaged with community partners throughout the process, through workshops, interviews, and surveys. And these partners have provided inputs on the scenarios that we're running, how they're described and visualized, and really how our whole kind of web platform is structured. And we're doing this in order to make sure that the information we ultimately share are as accessible as possible and as usable as possible. This image offers an analogy for how we're approaching our project. And I want to give credit to James Gilbert and a little bit of help from AI. This landscape represents basically the decision space for possible pathways for how we manage water into the future. As you can see from the the picture, there's sort of one clearly defined path that exists down the center of the image, and you could argue that this represents the pathway that most of our planning studies have explored, one that seeks to maximize the reliability of water deliveries from our Central Valley water system, including the State Water Project and the federal Central Valley Project. But there are pathways to other destinations that are less well defined. These include, for example, a path to sustainable groundwater management in the Central Valley, a path to a healthy Bay Delta estuary, a path to the recovery of endangered winter run salmon on the Sacramento River. I do want to acknowledge that there have been other exploratory planning efforts in this vein that have been led by government agencies. But with COEQWAL, we're really expanding the range, I think, of possible decision pathways that have been considered to date. And with this in mind, I really want to emphasize that our scenarios that we are considering as part of this effort are exploratory in nature and are not prescriptive. So our goal is not to find, the best path for managing California's water, but to understand the range of possibilities that may exist and to understand what the costs and benefits and trade-offs of different options might be. As I mentioned earlier, for this project, we're using a water operations model for the Central Valley known as CalSim3. This model was developed by the California Department of Water Resources and the U.S. Bureau of Reclamation, and is primarily used to support long-term planning and decision-making around operations of the State Water Project, Central Valley Project, and connected infrastructure. It represents most of the major water infrastructure in the Central Valley, including diversion facilities that deliver water to the Bay Area and other parts of the coast, including Southern California. The model is extremely complex, and it's very difficult for organizations who don't have access to CalSim modelers to really understand and critique simulation results that are presented by state agencies and other well-resourced entities. So one of the goals of COEQWAL is to provide insight into how this model works so that a broader audience can participate in planning and decision-making processes that rely on this tool. Our project team includes over 70 researchers primarily from UC campuses, UC ANR, and CSUs. Our team includes social scientists, climate scientists, engineers, economists, ecologists, data scientists, and visualization experts. So this has been a really diverse multidisciplinary team. For this project, we've also established partnerships with a lot of organizations outside of academic institutions, with some examples highlighted here. And we've made a really concerted effort to engage groups who have not had a seat at the decision-making table, including tribes and other communities that have been underserved by our academic and government institutions. Our approach to collaboration has centered around the formation and engagement of a project steering committee and advisory committee, which includes about another 60 or 70 people representing the entities you see here. And over the course of this 3-year project, we've organized several in-person and virtual workshops, webinars, and interviews to um, solicit feedback and shape the direction of our project, including the types of operations and policies to consider in our scenarios, ways of communicating scenarios and scenario outcomes, the nature of our visualization tools. Really across the board, we've gotten a really valuable impact input from our advisory committees. I just want to take a moment to highlight some of the themes around which we've structured our scenarios. Um, One of our themes focuses on community drinking water needs, and it really asks whether people, and, communities can access reliable, safe, affordable drinking water. And this includes scenarios that prioritize water deliveries to community water systems at different levels of service. A second theme around which we've developed scenarios considers the relationship between groundwater management and agricultural productivity. And this theme specifically explores scenarios that simulate how restrictions on groundwater use, aligned with the requirements of the Sustainable Groundwater Management Act, affect crop production and revenues, as well as trade-offs with groundwater storage and other uses. A third theme considers flow needs to support salmon populations and ecosystem health. And in this theme, we've explored scenarios that modify or enhance environmental flow requirements beyond existing minimum levels. And we've also explored scenarios that modify reservoir operations, including for Shasta Reservoir and flows in the Sacramento River in order to improve conditions for winter run Chinook salmon. And then a fourth theme is explicitly place-based and is focused on the Sacramento San Joaquin River Delta. And scenarios in this theme explore how specific changes in operations, regulations, and infrastructure might affect the balance of trade-offs between communities, farms, and ecosystems. For each of these scenarios we explored, we also evaluated how outcomes shift under alternative hydroclimate futures. Our approach is aligned with one taken developed by the Department of Water Resources, where we basically create different sort of realizations of possible hydroclimates, changes in precipitation, temperature, and inflow into reservoirs that are informed by global model projections and represent different levels of risk to our water system. And I won't get in the details here, but just wanted to highlight that our scenarios include this sort of wide range of kind of climate stress testing, if you will. One of the most important and time intensive elements of our project was how we expanded the suite of outcomes considered in our scenario. So CalSim 3 is a water allocation model. For a given water supply, it predicts how much water is allocated to different uses in different locations. But in many cases, people are interested in more than absolute water deliveries and how much water is going to be delivered to point A or point B. They want to know what these deliveries actually mean for the economy, for water quality, for recreation, for ecosystems. So as part of our project, we use linked models to translate CalSim model outputs into more meaningful, terms or variables. And so these models included an agricultural economic model known as OpenDAP that basically predicts how agricultural water districts will respond to changes or water shortages in terms of cropping patterns and ultimately in terms of revenues. A second model that we focused on was a three-dimensional hydrodynamic model, salinity model for the Bay Delta estuary to better understand how changes in inflows and sea level rise would affect salinity gradients and related uses, affected uses within the Delta. And then collaborators at NOAA Fisheries in Santa Cruz coupled calcium model outputs with a life cycle model for winter run Chinook salmon to understand again how changes in operations, flows, and cold water pool would affect populations of this endangered species. One of the the challenges that we faced very early in the project was in communicating this really broad and diverse suite of outcomes to an external audience. Here's just an example of the type of graph that we shared in one of our first public workshops that illustrate differences between a subset of scenarios that affect, conditions in the delta. So, I mean, here we see differences among the scenarios. So each line basically represents a different scenario, and that's vertical distance on the line for these different variables show what the associated condition is. And so, for example, we see that average Shasta storage across these set of scenarios ranges from about 3.1 to 3.4 million acre feet. But the significance of this magnitude of change for that variable and for all other variables isn't meaningful. It's not clear what that actually means, what the consequences of those differences really are. And it's also not clear whether or not the trade-offs evident among our scenarios are meaningful. So for example, we can look at a scenario in orange that shows enhanced delta outflows, and we see, yes, indeed, we see higher delta outflows, we see and lower salinity, for example. But what are the nature of trade-offs within and across scenarios, and are they actually meaningful? This led us down a path to develop methods that enable more meaningful comparison among our different types of outcomes. And this figure just basically shows the primary outcome categories that we were interested in: drinking water supplies to community water systems, salinity in the delta and its implications for delta exports as well as for in-delta uses, environmental flows in rivers, reservoir storage across the Central Valley, groundwater storage and conditions, the health of the Bay Delta ecosystem, winter run salmon abundance, and agricultural impacts as well, expressed as agricultural revenues, again, modified or expressed through that model I mentioned. So how do we do this? The solution we came up with was essentially a tier-based or needs-based approach in which we define changes in conditions relative to different performance thresholds. And so this image here illustrates or highlights the nature of the problem, where the impacts of a specific level of water shortage to a particular user is difficult to interpret. So what does it really mean for this particular user to experience some level of shortage? So what we've done is we've defined a series of thresholds based on our understanding of the sensitivities or vulnerabilities of different user types to shortages, and set these thresholds defined as critical, at-risk, acceptable, or optimal conditions. And this helps us to contextualize shortages relative to actual needs or impacts. So in this case, this hypothetical level of shortage suggests that water users, this water user is at risk of experiencing impacts, but isn't necessarily at a critical state or below a critical state. We've established these thresholds levels for 9 key outcomes, distinguishing again between optimal, acceptable, at-risk, and critical states. And this framework, again, was designed to reflect the unique sensitivities of different outcomes to water shortage stress, A reduction in 10% of water supply in a year or over the long term is very different for a community than it is for a river than it is uh, for a agricultural water district, for example. This framework also gives us a common scale for assessing multiple outcomes, and it helps us to better understand the nature of trade-offs both within and between different outcome types. So this is an example of how we define outcome levels for agricultural revenues, where we just defined optimal conditions as revenues that remain stable or increase. Revenues that decline less than 5% were considered acceptable, with increasing, risk shown at these lower levels. Um, this sort of translation framework also allows us to sort of simplify the visualization of our results. So here's a map of agricultural outcomes, revenue outcomes, evaluated 132 agricultural demand units across the Central Valley for current operations. So what we can conclude here is that under current operations, water deliveries to most of our agricultural water districts result in optimal or acceptable revenues, but there are districts that are considered in at-risk or critical condition, as you see, particularly in parts of the San Joaquin Valley. So I don't have time to get into the details of all of the scenarios that we ran and all of the detailed results and outcomes that we evaluated, but I want to give you just I guess, a snapshot of some of our findings. So here's an example of a radar plot that shows the results of two scenarios. We're comparing current operations and one in which groundwater pumping is limited by agricultural water users in the Central Valley. The greater the distance that the points are from the center indicates better performance. And it's basically aligned with those tiered scales that I described earlier. And so here, basically, we see that if we compare the sort of the green, which is the scenario outcomes for the scenario in which we limit groundwater pumping, with that in under current operations, we see that agricultural revenues decline, but particularly in north of Delta. So we don't see as big an impact south of Delta. We don't see changes in environmental flows, and we do see the anticipated increase in groundwater storage and also in reservoir storage. This is in part because in this scenario, we consider groundwater pumping limits in addition to the expected reduction in agricultural land use. So we think this signal represents a reduction in ag water demands that potentially results in higher reservoir storage. At the same time, it's sort of interesting. We see that freshwater uh, exports out of the Delta actually increase relative to the baseline. So that agricultural revenue impacts are kind of offset, I think, by to the south of Delta, are offset by increased exports from the Delta, but no noticeable improvements in environmental flows or the Delta estuary ecology. Here's another scenario that involves enhancing environmental flow requirements. So here we um, basically set new environmental flow standards for every river tributary to the Sacramento and San Joaquin River, and define them as they're as basically according to a science-supported framework known as functional flows. So these in generally represented a significant increase in the water allocated to rivers, specifically and most often in the spring. And what we see for this scenario when we compare to the baseline is that, as expected, we see notable improvements in environmental flow outcomes for the rivers that received these higher priority water allocations. We see that sort of increase in river flows was sort of offset by decreases in ag revenues, particularly south of Delta this time, as well as decreases in reservoir storage, both north and south of Delta. We don't see major or significant effects on Delta uses, exports, or the Bay Delta ecology under this scenario. So again, like these types of scenarios help us to understand the sort of the broad trade-offs. And then for any one of these, and I again won't have time today, we can sort of delve into the spatial dimensions, into the specific nature of impacts. But I just want to give you a sort of a flavor of the scenarios that we're exploring and the type of data that are coming out of these analyses. I'll give you one last example, which is a scenario that enhances cold water storage in Shasta Reservoir and enhances flows for winter run Chinook salmon. So here we see that changes in operations don't actually meaningfully improve salmon abundance when salmon are restricted to their current distribution below Shasta Dam. So for those of you who aren't familiar with winter run Chinook salmon, this is an endangered species. Its access to its historical range was blocked by the construction of Shasta Reservoir, and it currently exists only below Shasta Dam. What we've done with our partners at NOAA Fisheries was actually explore a sort of derivative of this scenario in which a reintroduction of salmon above Shasta Dam was enabled. And in this case, that's shown as the open blue circle. We see that we do actually improve winter run salmon, not to an acceptable or optimal state, but an improvement nonetheless. I'll also note that this scenario does not include habitat restoration or other management actions that could potentially benefit salmon. And this is one of the, I think, important limitations of CalSim 3 is that it's really, again, designed as a water allocation tool and to explore how different changes in operations affect the sort of the flows or movement of water across the region. It doesn't, sort of explicitly consider other types of management activities that involve, physical changes in the landscape, habitat restoration, et cetera. So just to give you a sense of what's coming when we release this web platform to the public, we have explored and run a suite of 24 management strategies under 5 distinct hydroclimates, or have 120 total scenarios to share. These scenarios are characterized by really dozens of outcome variables that explore the elements or the outcomes that you see here: community water system deliveries, agricultural district deliveries and revenues, the flows needed to support river ecosystem health, and the Bay Delta estuary. We have this particular emphasis on winter run salmon populations, as well as evaluating reservoir and groundwater storage. So I'll say that we're still working to, I think, fully understand what the results of our scenarios are telling us, but it's fair to say that we've begun to identify pathways to these alternative water futures, in addition to uncovering some new questions along the way. In the last few minutes, I just want to share a little bit more about kind of how we're approaching the development of this data platform and what success looks like to us. And so ultimately, the way that we want to measure or evaluate success for this project is if folks like on this webinar today and others can actually access and interpret the data that we're sharing and effectively use it to advocate for their own water interests. And so, this really goes beyond making data physically available, but also, easy to find, understand, and contextualize. And so these layered levels of data access are really embodied in the design of our web platform, where again, we want to go beyond just making sure the data can be accessed, but we're thinking a lot about um, the file formats that we're providing data in, the metadata that we're using to document our our um, our scenarios. And then, arguably most importantly, and what's really been actually the one of the biggest lifts for this project is thinking about what it means to make these data actionable. And so we spent a lot of time developing really educational information on water literacy concepts that are needed to work with these data, various summary products that can be helpful for distribution, and for different audiences. And I think this is where our work around, sort of trying to develop more, sort of meaningful, accessible outcome variables fits into our work. Here's a screenshot of our of our landing page, just to give you a flavor of what this is going to is going to look like. As you scroll through the site, you'll see that it's sort of structured around these three sections: learn, explore, and share. The learn section includes materials designed to introduce our audience to really foundational concepts that are needed to interpret the data we're sharing. So we have a scrolly telling learning module that explains how kind of water moves through California, our understanding of how climate is affecting California water, some of the details around the way water's managed, our major water infrastructure, and some of the key kind of constraints on our system. And then we have another module that explores and how equity shapes California water, over time and today. The heart of our website is the scenario exploration section, where the specific scenarios can be explored and analyzed. This is just a screenshot of our Explore in sort of its list configuration, which displays a subset of the scenarios on the left, and a summary of key results or outcomes as bar charts to the right. And so with this type of interactive display, you can quickly scan the different scenarios that are included in our library, and organize them by themes or by individual scenarios. There's a scenario search tool. You can also click on specific outcomes and pull up visual elements and maps and take a closer look at how outcomes are distributed across the domain. There are other plots. So here's another example of the radar plot that I shared earlier that allows you to compare one or more scenarios along different outcome axes. And as users are kind of scrolling through various scenarios, it's possible to basically save different graphical elements or text blurbs that are of interest. And all of that material gets stored in the share section of the site, where they can be kind of revisited, reviewed, annotated, organized, and ultimately downloaded. And here, this is kind of where our intent is to sort of facilitate this transfer of information, from this sort of exploratory phase to ideally allowing our visitors to take away, meaningful features or data or information that they can use or share with others. For advanced users on our site, we also have a Get Data page where all of our scenario data can be downloaded, and where data documentation can also be found. We'll have an API for folks that want to directly interact with the data. And unfortunately, we're not prepared to share the site with you all quite yet. We are still making some final changes to the kind of the navigation and functionality of some of the tools, but we're planning to release the data platform website to the public in early September. So stay tuned for our public launch event. We also plan to be at the Bay Delta Science conference later that month to be sharing this work. I also want to mention that we've been awarded a new grant from the Delta Science Program to continue this work into the future. So that project will specifically explore how these types of tools and approaches can better serve tribal communities. So we'll be doing a series of activities to really understand the nature of tribal uses and relationships to delta waterways and floodplains, to see how we can incorporate those perspectives into this work. So we're really excited to build on what we've already developed and to take this project in new directions. And ultimately, I'll say we hope this site and data platform will really be a living database where we can expand our scenario library, develop new ways of assessing scenario outcomes, and build new tools that better serve our audience. So I'll conclude with just a couple of lessons learned, reflecting on these last few years of this project. I would say this project is really a meaningful first step towards democratizing California's water future. I think we've made great progress in building a foundation for sort of a common understanding of how California water works. We've built trust with a broad suite of community partners. And I think we've made progress, though we haven't fully succeeded in connecting our models and our data to the lived experience of project partners. So I just say like this journey has just begun, but I'm proud of the progress that we've made. Um, I'll say that we made a strategic decision to use CalSim 3 as the kind of the core model around which we've built this scenario approach. And that was, really led by the understanding that, working with an existing model can facilitate buy-in from key agencies. And because it's already used in these different planning contexts, we felt that, if we could provide information in using this calcium model, the products or our findings would be more likely to be actionable. But it's also true that this model isn't really well suited to address the diverse suite of goals and outcomes that we really want to consider as part of this project. And so there were some types of outcomes that we weren't in a position to evaluate as part of this project because of calcium limitations. I don't think I mentioned earlier in the presentation, but calcium is run at a monthly time step, so that also introduces some challenges for characterizing, some dynamics of the system as well as some management strategies that are going to be really important as we look to the future. So it's not a perfect tool for evaluating all of the different uses, needs, threats, strategies that we need to bring to bear on these conversations around California's water future and adaptation strategies. I think this approach that we've taken to sort of interpret the outcomes of our scenario results has really been effective in enhancing interpretation and accessibility. But I'll also acknowledge that additional work is needed to really vet this approach and to potentially develop tools that allow for more flexible definitions of different tiered thresholds. And I guess I'll just conclude by saying this has been a really meaningful um, project in the nature of our collaboration and bringing together, again, a really diverse group of researchers and partners. And I think the participants that we brought into our workshops and various engagement activities, felt heard. And I think the researchers felt that their work was really, having real world impact or connections, which isn't always the case with our research. And again, I think I mentioned this earlier, but I think this collaboratory approach has really provided opportunities for interaction among, I think, folks that are often not sitting around a common table to learn collectively and to get to know one another in ways that I think has a lot of value when we think about the challenges that we're facing collectively in the future. So I guess I'll just conclude by saying that, yeah, I think these collaboratory approaches for modeling and data sharing scenario exploration hold real promise, and I hope that we can continue to build on them. So with that, I just want to, I guess, thank you all for your attention. I want to thank the research team, particularly my co-lead on this work, Jovitska Medema, who's I think in the audience, as well as the research team that has I was really, I couldn't have done this work without the participation of really dozens of people. So I want to thank everyone, and I'm happy to open up to Q&A with Robin if that's the right time.
It is. And thank you so much for that presentation and for all this really great work to you and to that broader team. I selfishly get first cut at a couple of questions, but I've also noted that we've got a lot of really great questions in the chat already, and hopefully our kind of jumping off here into the Q&A will generate some additional questions from the broader audience. So I'll try and get out of the way pretty quickly so that we can turn to questions from everybody else who's joined us. I did have one that came up for me as you were speaking, Ted. So
Hmm.
with apologies
Okay.
for this being fresh for you, I did want to ask, the tiers that you all have developed seem
Yeah.
really, really important in terms of being able to make sense of the data and also for kind of building trust and understanding around what you all have produced. And I know that this kind of collaboratory approach was so critical and kind of underlining everything you've done here. So I'm curious if you could speak a little bit more to how you all developed those tiers and the kind of input that you sought as you did that work.
Yeah, I mean it was really an organic um I guess sort of concept that came out of a lot of different conversations. I think it was really the intersection of us grappling with this challenge of how do we make these data more meaningful, interpretive, that also intersected with, I think, a lot of interest and from our community partners on like how are we grappling with equity in this work. And I think this tier framework really represents the intersection of those two like challenges that we were grappling with. And on the one hand, the tiers, again, provide the sort of common scale when we translate these very different types of outcomes into this sort of four-tiered framework. It really facilitates, um, kind of enables comparisons across
Mhm.
our scenarios and across outcomes. On the equity side, it enables us to basically show, I think, in a more transparent way, how shifts in, say, water deliveries really affect or impact our different users. And I think, kind of building on a comment I made earlier, that like, let's say a 10 or 20% or 30% reduction in water supplies can mean very different things to different types of users. And this context is really important. Um, I think we knew that ultimately, I mean, we came up with I think defensible thresholds for defining these different levels, but we acknowledge that there's a level of subjectivity involved in this. And I think one of the things that we've really wanted to get to that I don't think we're going to quite get to in this phase is to enable users to actually set their own thresholds and explore the results in that way. So maintain this framework, but enable some flexibility so that if folks disagree with whatever thresholds are set, they can kind of understand, um, if they do modify it, what the implications of that might be. We did, after coming up with some initial ideas around this, we did this. This was the focus of a lot of our workshops, and so I would say that these were all pretty thoroughly vetted with our stakeholder groups. But I would definitely say that they're not quite a finished. It's an effort that I think will continue to require some refinement.
Well, I love that idea. And I feel like if you did allow people to set their own thresholds, that in and of itself becomes data, right? Because then
Yeah.
you start to
Mhm.
kind of better understand what those thresholds actually should be. It's kind of community sourced information in that
Yeah.
way, which would be really fascinating.
Yeah.
As a member of the advisory group for this project, I really vividly remember a fascinating presentation that you all did at one point earlier on about different ways to define equity.
Mhm.
And and when I was sitting through that presentation, I thought, man, it'd be really interesting to kind of maybe take that as a constraint set, right? Like have a certain definition of equity that you're applying, constrain the model to, or as like a first highest order outcome that the model had to meet first before then trying to sort of fulfill all these other beneficial uses for water. And I know that's not an approach that you all were able to take with calcium, but I guess I have kind of a multi part question for you, which is, could you speak a little bit more to
Yeah.
some of those different dimensions of equity that you all looked at in the work here, and then anything else that you would say about, opportunities to do more, to do better and kind of more robust modeling around that than you were able to in this initial phase?
Yeah, I mean, I think we gave a lot of thought to how, it's in the title of our of our project, and we gave a lot of thought to how we were defining and incorporating equity kind of concepts and dimensions into our work. There's the kind of the structural elements of like how we organized and governed our project in terms of, you know, making sure that we had, diverse representation, and we're really making, I guess, a focused effort to ensure that, voices that are often excluded from decision making were part of our both steering and advisory committee. So that kind of speaks to kind of structural equity concerns. Um, the there's the sort of the second component, which, and then I guess there's well, a second component is sort of how we consider equity in terms of access, like making this information accessible to everyone. That's an equity issue, right? So that's where I think that speaks to the strategies that we've used around sort of data, sort of visualization, science communication. And then there's sort of a third piece, which is how we actually, evaluate equity within our scenarios. And this is where I think we made some early attempts to like kind of operationalize and like come up with like equity variables, and then kind of backed off that a little bit, realizing that it's equity is like can be a helpful like framework, but like operationalizing it can be really difficult because people have very different ideas of what equity means. So I think what we actually ended up with was some of our visualization tools, which I actually didn't present today. I think can be were really designed to highlight equity dimensions of our outcomes. So for example, we can see in some of our data visualizations that, let's say, within the agricultural sector or within our communities that are represented in our model, we can see that some are consistently in this like top tier of performance, that regardless of what scenario you're running or what climate you're under, they're doing pretty well. And then there's others that are like pretty much doing poorly no matter what, or sometimes they're doing worse, poorly or worse. And so that to me speaks to concerns around equity, and that there's clearly some users there, water users, environment, other indicators that are sort of bearing the brunt of some of our of our scenarios. And I think if we can, by just making that transparent, it can facilitate conversations around equity. And I think as our users are exploring different scenarios and identifying scenarios that might align with their interests, we're trying to present the data in ways that make sure that those equity dimensions aren't overlooked, and then they can see, well, this is a scenario that works really well for me for things that I care about, but it looks like there's some problems for others. And so, before I go to the water board and advocate for this particular scenario or some version of this scenario, I need to like really kind of reconcile what this means for others. And that's the type of conversation that I hope will come out of this type of um, sort of data platform.
Yeah, awesome. Well, I have like 10 other questions that I'd love to ask, even though I've gotten to kind of be along for the ride a little bit. But I'm just noting there's a lot coming in, and I want to be
Okay.
sure that others get a chance. So I'll start us off by asking a related question that came in from Mike Antos. And Mike, I'll read it, but if there's anything you want to add after I do, feel free to come off mute. Um, but related to what you just sort of spoke to, he asks, are there any dimensions that are sort of untouched if you drop all the radar plots on top of one another for all the scenarios that you ran? Are there any dimensions that are untouched by the different management options? Basically, like anything we can stop worrying about.
Mm. Wow. Um, that's a good question. I mean, I would say that like um overall, I was actually surprised, or have been somewhat surprised, at least for the scenarios under which we're running them under historical climate conditions, that even like what I consider to be like major changes in how we operate the system, changing priorities and flow requirements or delta outflows, or you know putting in new infrastructure, like the magnitude of change in a lot of our variables wasn't as actually as as significant or as large as I originally anticipated. And I think this really speaks to the fact that like we have like a very constrained and interdependent system, and that even when you like change one lever like in a significant direction, there's still so many other constraints that that limit how that restricts sort of how water can be moved around. That can be infrastructural constraints or just water availability constraints or this or that. So I mean, take that for what it's worth. I mean, I think, for me, what that means is that one, like it's not like there's like one solution that's going to
Mhm.
like work for everybody. There's not one solution that's going to dramatically change the situation for everybody. We're kind of stuck with the system that we have, and that we really need to explore kind of multi-strategy solutions at the same time, which is not really what we did with CoEqual. Because with CoEqual, the way we designed these scenarios is we tried to sort of isolate individual actions so you can understand the consequences of single actions relative to like some baseline, because otherwise it becomes almost impossible to understand why we're seeing the changes that we are. And so I think that's my takeaway, is that like in the next phase we really need to think about, okay, how do we actually carefully balance these different strategies so that we can try to elevate, get those those that are left behind up out of those critical phases, while also kind of balancing the benefits across these very different user types.
Yeah. It seems like there's a lot left to do in next phases. Elisa, I'll turn to you. I know you've been kind of monitoring
Yeah.
the chat, and I can also help do that for the next ones that come in as you pose a few of the questions that are left here.
Yeah, I'm actually going to invite Claire to see if she'd like to ask her question. Claire, you should be able to unmute and start your video.
Yeah, thanks, Alyssa. Ted, this is amazing work. Great presentation. I just wanted to echo what you said. Without like these modeling exercises, attribution for like which parts of the water cycle are affected by any one water use is like virtually impossible because there's so much underlying complexity that you almost have to make those comparisons to see the why, like you said. My question was about how this might interact with other ongoing programs like Sigma and the multi-benefit land repurposing program. And
Um,
I expect GSAs or even just community stakeholders would be interested in using these tools to make to foster conversations about these hard choices everyone has to make about land use transitions. But I'm curious if you think the model is too large scale to sort of influence that local decision making, or if you think if that's one of the goals of the project.
yeah, no, it's a great question. I mean, when we kind of convened some of our early stakeholder meetings, that was one of the main sort of areas of interest, which was around groundwater management. And that's not something that has really been done before with calcium. Calcium does have a coupled groundwater model for the Central Valley that basically looks at how basically changes in surface water supplies if there's shortages, how that can then result in pumping of groundwater. But Sigma, or some approximation of Sigma implementation, isn't explicitly represented in calcium. So that's something we actually developed as part of this project. And so I do think that our initial scenarios can help to identify locations where are sort of hotspots on the landscape, where it seems like management interventions would be needed, some places that are more vulnerable or less vulnerable to pumping, and what happens when you do restrictions, how those impacts kind of propagate across the landscape. A couple limitations of our approach is that one, sort of calcium is run at a monthly time step and not a daily time step. And so, there's a lot of interest right now in managed aquifer recharge, and trying to accelerate, groundwater recharge to compensate for, long-term overdraft, and to make sure that that resource is available in future droughts. Model's not really set up for that, because you really need to get at daily scale flood dynamics, I think, to get a groundwater aquifer recharge. I think a second limitation of calcium is that it's currently configured to basically have a static representation of land use over every simulation period, so it doesn't dynamically change land use. And so if you wanted to look at like land repurposing scenarios, you'd basically have to run every land use configuration, you would have to run sort of as a static realization and then run that through. You could totally do that, and you could start to piece out, I think, how land repurposing might change the sort of the balance of impacts and benefits, but it would be a little bit unwieldy. But you could, yeah, that would be the approach.
Ted, not surprisingly, you've got a few questions that have come in on the climate change scenarios. So
Yeah, yeah, I
I'm
didn't
going to
talk much on that.
kind of try and summarize across all because there's three or four.
Okay.
So the first one asks whether you can speak more on the climate change scenarios and did you incorporate stochastic uncertainty? We had another question come in about salinity in the delta, and to what extent X2 historical data was included in your climate change impact analysis. And then finally, somebody from DWR asking about whether or not you consolidated snowpack. Let me try to get to that. Um, oh gosh, where is it? Here it is. Have you considered, 1/3 of our water supply comes from snowpack. Have you considered snowpacks in your simulations?
Yeah.
And he sort of spoke to WEAP and future scenarios modeling under WEAP. And I'm so sorry, whoever wrote that I'm butchering it. But I wanted to kind of give you a sense of the range of
Yeah.
questions you were getting on the climate change modeling that was included.
Yeah, I didn't get into much detail around our technical approach for modeling different hydroclimate futures. This is another, I think, uh, weakness or limitation of calcium 3. Essentially, calcium 3 is currently configured to run a historical time series of 100-year simulation period representing our historical time series. So 1920 to 2020. It's actually adjusted to account for recent climate change because the idea, kind of the, I guess, sort of the ethos or the sort of the idea behind these calcium runs is that you want to try to expose the system to some range of possible range of climate variation that kind of characterize the history. When you implement the climate futures, you're actually perturbing the historical time series. So you're actually preserving the sequence of years over that 100-year simulation period, but you're kind of shifting the statistics of that interannual variation based on our global climate modeling data. And there's actually kind of two kind of parallel approaches that we explored, but one was very much aligned with the approach that DWR used in their um, delivery capability report that came out recently, where they used sort of a stochastic weather generation kind of stress test approach, where they identified different levels of sort of climate risk by mid-century that the system could experience, and then designed these 100-year time series to represent that level of risk. And so that's probably the clearest way I can explain it now without getting into a lot more technical detail. But I would say that like all of our five, we have our historical climate and then our four alternative climate series, and those are all sort of represent different levels of risk that by mid-century that align with kind of the ensemble of projections for the state. Those climate time series include projections of temperature, precipitation, and those are run through a hydrologic model. We use VIC. This is work led by Morgan Levy at Scripps to sort of translate those climate changes into runoff into our reservoirs or inflow into our reservoirs. And so changes in snowpack absolutely is a sort of embedded in that in that approach where warmer temperatures and changes in precipitation patterns will affect the accumulation and runoff of snow. And so in our more extreme climate scenarios, you can assume that there's much less snowpack or much earlier runoff periods as we expect with climate change.
Okay, yeah, I know that's always a tough question to answer
Mhm.
succinctly, so thank you for that. Um, there's another question, and Elisa has reminded folks in the chat, if anyone wants to just raise their hand and sort of speak their question verbally, feel free to do that. We don't need to be the middlemen between you and Ted unless you prefer for us to read your questions for you. Um, There was a question that came in, I think, as you were speaking still, which was how is managed aquifer recharge dropped into the modeling assumptions? Maybe you spoke a little bit to that already, but thought I would.
Yeah, no, it's not. Like we don't
Yeah.
consider in our scenarios that involve changes in groundwater use. Essentially, we have some scenarios that limit groundwater pumping to sustainable levels, and others that couple that limit with changes in land use. But we don't include any representation of managed aquifer recharge to sort of compensate maybe for that for or augment groundwater supplies. And so I think you could consider like the scenario as sort of like maybe kind of a worst case scenario, if you will, in terms of impacts on ag. If in theory, if you did actually implement managed aquifer recharge at scale, you could really offset, I think, some of the impacts that we're observing in our models simulations.
Okay, great. Elisa, are there any that are in the chat that I haven't seen or that I missed?
I guess there's one about partners. Have you all worked with the State Farm Bureau at all? I think that question comes from Carrie.
I don't think the state, no, I don't think we've had representatives from the State Farm Bureau on our advisory, in our advisory group. We have had other representation from agricultural, water districts, but not that particular agency.
Okay,
But
great.
happy to organize a briefing or if this is a particular interest.
Yeah, I'm also just going to invite folks, if you want to raise your hand, it's under React. I can go ahead and unmute you and invite you to just like speak your question. Oh, looks like Steve is wanting to ask this question. Go ahead, Steve.
Yeah, thank you. I'm just trying to relate this to earlier analysis that have been performed historically. And what comes to mind is the Colorado River Basin Compact and the assumptions that went into it of a very wet period of time as it relates to climate and the allocations, fixed allocations.
Mhm.
What I'm gleaning from this is a more an approach that is more timely as far as the information, much more dynamic. But then the question is, how does that become a tool in which, let's say, key partners, and I don't know if that's, let's say, at the state level, the legislature, or looking at within the state water project and the Central Valley Project, and that being the forum. But I see a lot of opportunity from this. But again, I think there's impediments on how robust it could be if it's being looked at as a decision-making tool, shall we say, based on equity.
Yeah, thanks for that comment. I guess I don't characterize this data platform as a decision-making tool as they're often defined. I think it's perhaps a decision support tool, but not a decision-making tool. I think I guess I can imagine this being used in a few different ways moving forward. I think there's opportunities for this to be used in communication and education, right? We in California, people for good reason don't really understand how our water system works, right? It's very complex and it's really hard to understand. Just put climate change out of the picture, just how water is moved around this state, where the constraints are, and what the implications are of how we manage the system. Like I think this type of tool where we've really done a lot of work to try to make this information accessible and very transparent and visible can play a role in that. And that I think aligns with DWR would benefit, would be interested in that, and other agencies that benefit from a sort of an educated and engaged public. I think there's certainly more to be done, but I think the work that we've done around climate risk assessment helps to highlight some of the kind of the fundamental issues that we're grappling with as a state as we look to a warmer and potentially drier future. Um, and then I don't think any of and I mentioned this a couple of times in my talk, but I don't think like any of these strategies should be, none of these are ready to be sort of taken off the shelf and like implemented and practiced. But I think, and what I hope is that some of these strategies sort of point us in maybe new directions that people aren't considering and say, oh, actually, like the impacts that we thought that this type of approach might have are actually somewhat overstated or not as big as we thought. So maybe we should explore this a little bit further and do more refined modeling and exploration just to look at feasibility and costs and impact. So I think every one of these strategies would require a much more detailed assessment to actually kind of move into implementation. But I think it does sort of help pose some new questions around like what really is possible. And I think that's a very timely conversation to have right now where it feels like our options are so constrained. We need to be creative, right? And how we move into the future. So I think in those different ways, I think the tool can be potentially useful. But I'm also like really curious to see how folks start using this once it's actually like released into the wild, so to speak, and trying to figure out how we can maybe make refinements to the tool so that it can really be helpful in different real world applications.
Really building very well off of that last point that you
Thank you,
just
Steve.
made, Ted. We just got another question from Corey. And she asks, how is the project approaching user and human-centered design and feedback into the site? Are you running pilot studies? And if so, what do those look like?
Yeah, I mean, uh, I think that was is a topic that we've been sort of mindful of throughout the process, but particularly in I'd say like the last year and a half, as we've been sort of taking our scenario runs and starting to figure out how to share it with an external public. I would say we primarily use these advisory cohort meetings to share um, you know kind of prototypes for the website, coupled with kind of we have a lot of activities where people just spend time with the site and then provide surveys, and we use that feedback to iterate. So I would say like we haven't used like maybe a super formalized sort of co-design process as part of the project, but it's something that for every one of our engagement activities, we've oriented some of our time to that end. We just had a workshop in April that was focused almost exclusively on that, where we gave people time to spend on the website. We had a lot of discussion and surveys, and that has then now led us to a whole nother level of sort of refinement to the site navigation. So I think that's sort of embedded in how we're approaching this work. It's work that I don't think will ever be fully done. There's always ways we can improve it, but I guess that's my brief summary of our approach.
Maybe I can follow up with a question of my own that kind of speaks to forward-looking phases for this.
Mhm.
You're going to put all that out there, and then you have a website that's live. Are you all exploring kind of funding mechanisms for continuing to, maintain that site? Are you
Yeah.
envisioning kind of a contact management system where people could flag like, hey, I actually think this tier should be defined in a really different way, and this doesn't reflect my lived
Hmm.
experience, right? So like,
Yeah.
is this intended to be a living site, and further updated and, additional runs added and things like that, or not, and how are you all thinking about that?
Yeah, I mean that's absolutely my hope and intention is to keep things going. We do have this opportunity through this recent Delta Science Award to continue sort of maintaining the site for the next 3 years and adding some functionality to it. We have colleagues that are going to be building out like a riparian vegetation kind of response model. So we're going to add one more like outcome variable that's going to be help us to represent kind of floodplain and riverine habitat responses to changes in flows and groundwater. Um, in the but in the longer term, yeah, we'll need to continue. We'll need to seek additional support from project partners. And then I guess to get at your question about like, yeah, like feedback, yeah, I think our we will have mechanisms on the site to basically collect feedback that way. And I hope we'll have some kind of bandwidth and opportunities to do some user testing, um, with different groups to understand how they might be engaging with this site and figure out, kind of set an agenda for, yeah, future scenarios, additional outcome variables, additional tools that will make it more useful. So yeah, I hope this will become a long-term sustained effort. That obviously getting off the ground is the big lift, and hopefully we can continue to refine moving forward. We'll have the lights on for at least 3 more years, and hopefully within those 3 years, if we can demonstrate real value, we'll find ways to keep it going.
Yeah, I'm sure you're going to get a lot of people with ideas of like what to look at next and things like that. So hopefully that helps. We have a raised hand from Chen Zhu, I think. Go ahead.
Yes, thank you. Thanks, Ted. Thanks, Robin, for this great opportunity to learn about the ongoing project in California. So so my background work on using seasonal forecast for smart water market. And so my question is, especially in the agriculture application, and people need to make the agricultural decisions, whether it's water use decisions, irrigation related to irrigation, or there's planting decisions or crop types. So my question is like when you run the ag economic modeling, do you consider all these different dimensions of decisions? To, are they optimized, or is it with the assumptions that with the current conditions, current scenarios? Thanks.
Yeah, that's a great question. I guess I'll have sort of two comments. I mean, like first is that, yeah, this is, CalSim is definitely like a planning tool for like longer term, like planning horizons. I would say like 30, 50, 100-year type horizons. It's not really very useful or designed for like, seasonal or short-term forecasting. But your question, I think, is really around like, yeah, to what extent do are we actually modeling, like what's the nature of the modeling of sort of crop type decisions? I think it's relatively simple, and I think it's informed by historical decisions around like when farmers experience water shortages in different regions, what are what are the changes in crop types and cultivation areas that we tend to see. And I think that is actually represented in this ag economic model, and which then gets sort of translated into, once I think it's basically water shortage gets translated into, sort of crop area and crop mix, and that gets translated into economic revenues, I think employment and some other indicators of the ag economy. But I assume, and I don't have our ag economic modelers I don't think they're on the call. Josue Medellin Azuera and Alvar Escrivá are two ag economic modelers, but I'm fairly certain that they don't include sort of some of the new, maybe more sophisticated, sort of forecasting tools that farmers may be using. But it would be interesting to think about like, yeah, like how would these tools like potentially change, the observed or predicted impacts of these different scenarios, and would those be, just really marginal, changes, or potentially transformative changes? And that we wouldn't know that until we actually, explore that scenario. But it's a really good question. Yeah.
I might sneak in one more. I don't think there's any that we've missed, and we're rounding out the hour and a half here. But I mean, as the California Water Data Consortium, I did want to ask one more sort of data specific question, which was, did you encounter any challenges kind of on the input side? There's a lot of development of input data sets that go into an exercise like this. I'm sure that's a huge part of the lift.
Yeah.
And I'm curious if you could speak a little bit to that and where, from your perspective, additional investment is needed to make these types of exercises more robust in the future.
Yeah, and I wish our colleague Kristen Dobbin was on the line. She's the colleague that really led our evaluation of kind of community, how we considered impacts and water deliveries to community water systems across the state or across the valley. And my understanding is that there were sort of inconsistent representations of community water system demands throughout the state, and actually there wasn't even actually a good documentation of how many community water systems actually rely on surface water deliveries from the Central Valley Project and State Water Project. Um, when we started this work, that became obvious that those data just didn't exist. And then where the community water systems that were represented with CalSim had very inconsistent um, sort of representations of their demand, which made it very difficult to then apply like the types of like uh, evaluation methods that we wanted to do to understand how shortages then translate into impacts. Because if you don't know actually what the needs are, or if you're not assessing needs in a consistent way for a community water system or for a different user type, it's basically impossible then to come up with a consistent way of measuring impact. And so that was, I think definitely one example where input data um, was limited. I would say, um, for our some of our environmental analyses, we had a life cycle model for winter run Chinook salmon, but not for other runs of salmon and not for other types of organisms. And so we were really limited in sort of what we could analyze, even though we knew that some of our partners were very interested in other indicators. And I would say like water quality was another big gap in our data. A lot of folks, particularly in the Delta, were really interested in understanding risks of like harmful algal blooms, for example, and that's not something that we were really able to address in this phase of the work, and that would really require a lot of additional modeling. So those are just some examples. I mean, yeah, it was every data set had its sort of quirks,
Yeah,
but
no,
we
appreciate
tried
that.
to do the best with what we had.
Really helpful insight. Well, I
Mhm.
think I don't see any new questions coming in, so I guess last word back to you, Ted, in terms of like what are you really excited about, looking most forward to on what's next for this? And before I let you give us your send off in that regard, I'll just thank you again, really sincerely, for the time today and for dreaming up this project with others in the first place and getting it to where it is now. So
Yeah.
thank you, and yeah, over to you for kind of
Yeah,
last
well, thank
thoughts.
you. Yeah, Robin, this was a great opportunity to share what we've accomplished so far. Yeah, it's been a very busy few years, and I'm incredibly excited to release this product out to the public and hear and learn what people think, um, and really just to move from this sort of internal development into application. And so. Um, we're very close. We're just a couple months away, and so I guess encourage folks that are still on this call who found this work to be interesting to stay tuned, and just to know that we're really interested in hearing what you have to say, and seeing how we can bring greater value to this effort.
Awesome. Yeah, thanks to everybody who stuck with us. And we got Avery and Elisa putting some reminders in the chat about signing up for our next Data for Lunches. Thank you again, Ted. And yeah, look forward to the site coming out and getting to play around with it some more.
Okay, have a great day. Thanks, everyone.
Thank you all. Take care.
Ciao.